For time tests, you don't have much time to review, especially if the tests are long. But if you don't have if you have extra time at the end of the test, you always want to go back and double check to make sure you didn't make any mistakes, calculation errors, this type of stuff. And so we could just do a quick check because, did I read the chart correctly? Was bicarbonate a stronger acid than hydrogen phosphate, right? And so, so here I'm going to go back and I look. Here's bicarbonate. Here's monohydrogen phosphate. So I see bicarbonate is a stronger acid indeed. And so bicarbonate is the stronger acid than monohydrogen phosphate. And so Kelly asked me where she went wrong on her problem. And what I saw was she had this is the acid, this is the base.
Why you can't do that?
Why? You can't do that because the way things react will be based on what you react it with. Even though monohydrogen phosphate can be an acid, it's not going to be the acid in this particular problem. It's not going to be an acid in this particular problem because there's a stronger acid present. An acid is, think of this as a tug of war for the proton. If there's a tug of war for the proton, right, so two sides are trying to pull the proton. Both of these can be considered bases, right?
Yeah.
And so think of this. Both of them are trying to pull the proton off the other species. What a stronger acid means is a stronger acid is easier to break the proton off. And so if both of these are struggling for the proton, which one will take it? Which one won't? Well, if we think in terms of just the acid, then let's see which one is easier to break the proton off. Monohydrogen phosphate or bicarbonate? Okay, it's bicarbonate. Why is bicarbonate easier to break the proton off? It's a stronger acid on the chart. So why is it stronger? I don't care at this point. It has to do with structure and composition. But it's a stronger acid. And so the stronger acid will always be the first to lose the proton because it's the easiest proton to pluck. Everybody's trying to pluck the proton off. It's going to be the easiest to pluck. It's like if you have a fruit tree, I want an apple. I'm going to get the hardest apple to reach. In fact, I'm going to go get my 10-foot ladder, go outside and pluck when there's one that's 5 feet off the ground. Which one are you going to do? Are you going to go grab a ladder, get the one 12 feet, or are you going to take the exact same apple 6 feet off the ground? You're going to get the one that's easiest. Nature works the same way. In nature, do you think nature is going to struggle and say, I'm going to pluck the harder proton off here because I just want to prove a point, right? No, nature is going to take the easiest proton off. So the strongest will always react first. And, don't overthink it. If it's stronger, that's the acid, right? Don't worry about why until later. All right, so we talked about this. What's the last possible reaction? Redox. Now, as far as redox goes, here you definitely need some factual knowledge, some experience. So sodium ions are oxidizer, lithium ions oxidizer, water is an oxidizer and reducer. Now, the reason is because bicarbonate and phosphate do not occur. In Chem 1A, I probably would have asked this, but in Chem 1B, not yet, because in Chem 1A, how much work did you guys do with oxidation numbers? Because we have people with different Chem 1A. Different Chem 1A instructors like to emphasize different things, you know. In my Chem 1A class, I like to emphasize things that are going to be applicable for, like, say, Chem 1B, you know, chemical reactions, that type of stuff. But it depends. So I know a lot of people, they didn't really cover this stuff that much. So I'm not going to talk too much about it just yet. But if you were going to expect this to be an oxidizer or reducer, or neither, what would your leaning be towards? Would bicarbonate be a reducer or an oxidizer, and why? It'd be an oxidizer. That's true. It's an oxidizer. Why would you say it would be an oxidizer? Well, losing a proton's not. Losing a proton's called an acid. An oxidizer gains electrons. What would be gaining the electrons in bicarbonate? And why? Okay, maybe this is the oxidation state. Carbon's in its max +4. It's not going to lose any, so it can't be a reducer. It's got to be an oxidizer. It can only gain. And so this would be an oxidizer. Then we think, you know, is carbonate a powerful oxidizer? You know, is carbonate on that chart? No, carbonate's a weak oxidizer. It's got to be weak, otherwise carbonate's so common, right? And so based on factual experience, we say that this has got to be a weak oxidizer. Now phosphate, what about phosphate? Phosphate's a bit unusual because phosphate is +5. +5 is very high, right? Have you seen other +5s? You've seen other +5s that are very strong oxidizers, but in phosphate, is phosphate a powerful oxidizer? You would think it would be with a +5 oxidation state on phosphorus, but you know, is phosphate on the redox chart there? Is phosphate a common chemical? It's a common ion. It occurs in lots of stuff, and yet it's not on that redox chart, which tells me that phosphate must not be a very good oxidizer. Right? And so that's a weak oxidizer there too. And so all these species are fairly weak. Sodium ions and lithium ions are not going to oxidize water, right? Sodium ions and lithium is stable in water. And so the end result here is I predict, probably no reaction. Right? Because carbonate and phosphate are stable in water. Are they going to react with water? Well, the only reducing agent present is H2O. And so no redox. Does it make sense? Mm-hmm. And so we went through them. Now, not everything occurs on the chart. One of the homework problems I threw out there, because you should know this from experience, ethanol. I don't know if I wrote it like this. Ethanol. Ethanol is not on the chart. So does that mean it's not a very good oxidizer reducer? No. Ethanol, everybody should know, is highly flammable. That means it combusts easily. Combusts easily, it must be a powerful reducer. Yeah, powerful reducer. And so this is the tricky one that I threw on the homework, and that's ethanol. Why? Well, ethanol is what we call electron rich, right? Species that are electron rich, like sodium metal, ethanol, are highly flammable. What makes ethanol electron rich? These carbons, you look at these carbons, this one's 2, 4, 6, this is -2, this is 2, 4, 5, this is -1. These are electron-rich carbons here. What happens when carbon loses electrons? Well, what happens when you burn ethanol? What do you form? Well, let me just tell you. Carbon dioxide. This carbon is +4, so we're going to go from -2 to +4, -1 to +4. This is called complete combustion. This is called a skeleton half reaction. Do you know how to balance skeleton half reactions? to get the balanced half reaction. What time do we go till today? 55. Oh my gosh. I'm way behind schedule. But maybe it's worth it. So this semester I'm spending more time on the chemical reactions. I pass out. I'll post some old exams on Piazza, but I do things differently each semester. But, I think when Raheem took it, I didn't spend that much time. It's a little different. But anyway, let me show you how to do this. How to balance out skeleton half reactions. Skeleton half reaction is we have the major reactant and we have the major product. Skeleton half reactions, we always ignore water and hydrogen. So we balance out all elements other than hydrogen and oxygen. So over on this side we have 2 carbons, on this side we have 1 carbon. And so we balance it by multiplying by coefficient. And then we balance the oxygens. We have 1 oxygen on the left and 4 oxygens on the right. How do we balance this? By adding
3 more waters.
3 waters. Good. And then we balance the hydrogens. 3, 6, 6 and 6 is 12 hydrogens and 0 hydrogens. And so we add 12 H+. And then we balance it by the charge. Neutral, neutral is 0. This is neutral plus 12 electrons. And then we get the balanced half reaction. The balanced half reaction is going to be ethanol, CH3, CH2, OH, plus 3 waters yields 2 CO2s, plus 12H+, plus 12 electrons. This is a good reducing agent. Look how many electrons are produced. 12 electrons per mole of ethanol. It's a good reducing agent. Really electron rich. And so this is the balanced half reaction for this. And then we have some other balanced half reaction when we combine them. So you'll need this for your homework. Complete one of the problems. That was more of a challenge problem. Maybe not for Chem 1A I cover this, but maybe for those who haven't had that, do this. All right, I got to stop here, and so we'll talk about complexes next time. What lab are we doing tomorrow?